Hello, good morning. This is Kavita, and today I'm going to show you what is galvanic cell and how it is different from an electrolytic cell. So let us understand what is the meaning of a galvanic cell. First of all, I will make it very clear. So galvanic cells are those cells which are going to convert the chemical energy into electrical energy. So that's the first thing, that they will convert the chemical energy into electrical energy. The second thing is that the free energy is negative, that is, gives free energy is negative, which indicates that it is a spontaneous process. Now, spontaneous processes are those processes which take place on their own without any human intervention. So we don't have to do anything, the cell functions on its own. Now, in the given cell which I have taken, the example is Daniell cell. Okay, so let us understand what is a Daniell cell comprising of. It consists of two half cells, as we discussed. We are going to have a container in which we take ZnSO4 and we take a zinc rod. So the combination of a metal kept in its own salt solution is called as the half cell. So that's my half cell, and that's called as oxidation half cell. Similarly, I have another beaker in which I take copper sulfate solution and I have got a copper rod dipped in it. Same way, this is going to be known as the reduction half cell. And what's happening here is that the zinc is going to get oxidized and the copper ions are going to get reduced. Now, why is this happening? It's very simple. We have already seen that zinc has a greater tendency to release electrons and become stable Zn2 plus ions. And copper 2 plus ions, which are very unstable, are having a good tendency to accept electrons and become copper. So in this entire world, we can say that all those metals which are very unstable, they would like to give electrons and get oxidized, and hence we can use them as anode. And similarly, those ions which are very unstable, they would like to accept electrons and become stable metal ions, and they will act as cathode, and reduction can take place. If we combine two such cells with a higher oxidation potential and the one with a lower oxidation potential, the combination is going to give us a galvanic cell. That is nothing but an electrochemical cell. So here also we do the same thing as we have discussed. We are also connecting a salt bridge as an internal circuit. The function of salt bridge is simply to connect the internal circuit, and also it helps in supplying the counter ions which will neutralize the excessive ions produced in the half cells. These electrodes will be connected by a conducting wire. When we do this, we know what happens here is that at anode, zinc releases electrons and zinc gets corroded or zinc gets oxidized. So the concentration of zinc ions starts increasing on the left hand side, and to utilize this charge, the salt bridge is going to supply the counter ions. That is your, let us say I have taken KNO3, so it will be the nitrate ions which will be traveling from the salt bridge, and they will utilize the charge which is present on the zinc ions. Similarly, on this side, that is your cathode, which is a positively charged terminal. The copper ions from the solutions accept electrons and they get reduced to copper. So after some time, we will see that the concentration of copper ions decreases in the right side beaker, and the concentration of sulfate ions rather increases, and hence to neutralize this excessive negative charge on the right side, the salt bridge is going to supply the potassium ions, 2 potassium ions, and in this manner the neutrality is maintained. Otherwise, these negatively charged ions will be surrounding this positively charged electrode and they will act as a barrier for the conduction of electrons. Similarly, over here, the zinc ions might surround the negatively charged electrode and would cause a barrier. So to avoid this barrier and to maintain the flow of current, we are going to use salt bridge. So we've understood here the salt bridge serves two functions. That is, the first one, it connects the internal circuit, and secondly, it supplies the counter ions which will neutralize the charge present in both the beakers. So that is the Daniell cell's complete makeup, and you can just add up this and just when you get a zinc rod and copper ions, when they react together we get zinc ions and copper. So that's your spontaneous reaction, and we see the EMF which we get from this cell is maximum 1.1 volts. In reality, when we did this experiment, you saw I took a very dilute solution and the voltage was 0.5 to 0.6 volts. So that's the Daniell cell. And what's the difference basically between an electrochemical cell and electrolytic cell, which we discussed in a previous video, is simply that in electrochemical cell it's a spontaneous process. It's going to be having a negative delta G, that is happens on its own. Chemical energy gets converted into electrical energy, whereas in electrolytic cell the reverse is going to happen. That is, the electrical energy we are going to supply, that is direct current, and we are going to cause chemical reaction. So that is going to be a non-spontaneous process, and delta G is going to be positive for that. So we are going to do that process. So these are basically the two types of cells which are commonly used for doing work.
So this is the anodic half zinc and this is the cathodic half copper. I'm going to dip zinc rod in this beaker and the copper strip in this one. Let's do it. So here we have the setup of both the half cells ready. Now zinc becomes the anode, that is negative, and copper becomes cathode, positive. It's called oxidation half cell because here zinc will be giving electrons and copper is called reduction half cell. For salt bridge, I'm going to use filter paper which will be dipped in potassium nitrate solution, that's an inert electrolyte. So here is the setup, and now let's fill them with the solutions and our cell would be ready. Before that, we screw up the wires properly and make proper connections. After adding the solutions, the setup looks like this: zinc sulfate colorless on the left side and copper sulfate blue on the right side, like this. We connect the beakers by a salt bridge which will supply the oppositely charged ions to both the beakers and maintain electrical neutrality and acts as a connection. At the back side, we have a voltmeter which is going to give readings only when the connections are correct. That is, negative connected to negative and positive connected to positive. So after doing the correct connections, that is zinc negative connected to negative terminal and copper positive connected to positive terminal, I get some readings over here. My cell has started functioning. So that was my galvanic cell.